Hello, everybody. Thank you so much for joining us on our first ever virtual joint student chapter meeting. As a reminder, this session is being recorded and you will be sent a recording later this week. Today's meeting will be run as a discussion, so please unmute yourself when you do have a question and then remember to mute yourself again. We will take turns asking our questions and we trust you all to remain organized during this time. So we're just going to let people ask their questions and then just be polite. If you wanted to take a turn, you'll just go next time, okay? So today we have Rob Boguski and we have Gary Tanel with us to lead our discussion and answer your questions. So thank you guys so much for being here. And now I will turn it over to you for self-introductions.
Very good. Thank you, Tom. It's a pleasure to be here with you and with Rob. You are both wonderful examples of what's great about SMTA. So can you hear me okay? Yes. Good. Okay, fantastic. So on the self-introduction side, I've been an SMTA member for 27 years, and probably 24 of those 27 was as an officer of SMTA, either at the chapter level or the 6 years that I was on the board of directors from 1996 until 2002. Rob has the pleasure of being on the board of directors at this time. So I'm a registered professional engineer. I did 10 years of engineering at Texas Instruments, 10 years of engineering management at Texas Instruments, 10 years of entrepreneurial, where I started my own company. And now I just help people and companies find good suppliers. And I enjoy talking to student chapters, giving presentations, encouragements, and whatever I can do to do that. So I run a company called the Electronics Alliance, which is a rep company. So I represent engineering, design, and manufacturing companies throughout Texas. And it's a pleasure to be with you here today. Rob?
Thank you, Gary. Thanks, Tam, for hosting this today. I'm Rob Boguski. I'm the president of a company in Silicon Valley called Daytest. We're a group of test engineers. What we do is we do analog and digital testing and failure analysis of printed circuit board assemblies, and we have a variety of tools to do that. I have been in the industry now for, next year will be my 46th year. I started as a teenager. My parents owned a printed circuit board fabrication company here in San Jose, and I learned to make a printed circuit board when I was in high school. That was not the career path. I was originally going to be an academic. My original intent was to go into economics, get a PhD, get a job at a university somewhere, and teach for the rest of my life. And it's probably by the grace of God that I didn't do that, because I've learned over the years that I have no patience for academia. So I probably would have flamed out there at some point. I'm way too blunt, which is much more appropriate for a business setting. And through a whole variety of strange twists of fate, I ended up in this industry. I ended up, after graduating from college, working in my parents' board fabrication company for a number of years, actually a total of 22. And then after that, worked in the contract manufacturing business for about 11 years. And then most recently, in the last 15 years, with some overlap of my contract manufacturing career, worked in the test engineering field. And that's where I am today, owning this small company here in Silicon Valley. I've been an SMTA member now for about 11 years. Been a chapter officer for the last 7.5, was a chapter president for 3. And as Gary just said, I'm currently a member of your board of directors. So happy to be here and talk a little bit and take a lot of questions.
Perfect. Well, I just want to remind everyone who just joined us that this is a discussion. So when you would like to ask a question, please feel free to unmute yourself, ask your question, and then remember to remute yourself. I'm going to start us off. I do have a question for you. So what is one piece of advice you got as a student that you feel has served you well in your career?
Go ahead, Rob.
I'll take that. Several professors told me, in effect, education is just a beginning. Don't assume that when you graduate, when you get that diploma, that the inputs end. The inputs are only starting. Education is a lifelong endeavor. And if you approach it with that attitude, with an open mind and a willingness to learn new things, particularly things that aren't necessarily related to your original field, you're going to expand your horizons, you're going to improve your life, and you're probably going to enhance your career.
That's a great answer. And the other thing is, when I started, I co-opted and interned. And some of the things I learned during that internship after my sophomore year was of great help to me the last 2 years of my college. And so the advice that the professional engineers gave to me while I was in school that I followed was be open-minded and look at life as problem solving. Okay, the answers aren't all over there; they're not in the book. Sometimes you have to blaze new trails. So be creative. Your job as an engineer is to solve problems.
So I'm going to ask another question. Again, if you do have a question, please just remember to unmute yourself because this is just a discussion. So we would love to hear from you. So what is one thing that a student or a young professional could do now to make themselves more hireable in the future?
Okay, well, I'll start off with this time, Rob. A number of things that I think you want to think about is a lot of engineers are pretty much introverts, and they're very quiet and very technical nature, and they tend not to sell themselves because they rely on their technical abilities. But when you want to get hired, you not only are an engineer, you also are a salesperson, and you have to be a salesperson for yourself. You have to sell your skills to somebody else. It's uncomfortable for a lot of engineering students and engineers generally to sell themselves. So you have to work on your interpersonal skills, push yourself a little bit more so you're comfortable talking about your accomplishments without coming across being braggadocious. Work on your communication skills. A lot of times engineers will give just a short, yes, sir, no, sir, answer. What they're looking for is a little bit longer embellishment of the answers. So don't give short little snippets of the answers. They're looking for an insight in how you think. So just not yes or no kind of answers. You got to sell yourself. And if you're preparing before graduation, broaden your horizons. Don't rely on GPA and your thesis to sell you, okay? Join associations, specifically SMTA, as you are right now. You're getting a benefit right now that a lot of other students don't have. But, IEEE, SME, SMTA, get involved in the industry. Make friends in the industry that are not academia, because they are the ones that will give you the advice to be hired.
I would just add to what Gary said. A number of years ago, we had an internship program pairing our company with the University of California at Davis. And 10 engineering students at a time would come through our facility for a tour to get some idea of what we do and whether it would be interesting for them for an internship. And we'd have 8 or 9 out of the 10 would never raise their hand. You'd open it to Q&A and they'd just sit there. And the people who got the internships were the people who raised their hands and asked questions. And it's really funny because out of one group, we had 1 young lady and we had 9 young men. The young lady got the internship because she was the one who came prepared. She'd learned about our business and she asked very pertinent questions and put us on the spot in some cases, but we really liked that. And I appreciate that because I'm a natural introvert. Doing that sort of thing is hard work, and I understand and I'm sympathetic to the effort that goes into doing that. But Gary's right. In order to sell yourself, in order to put yourself out there, you have to a degree, come out of your shell and be extroverted, at least to the degree that you can make people notice you, make people want to respond to you, put questions to them and dialogue with them. if you're not willing to do that interaction, then that's gonna be an impediment to your advancement. So you need to really screw up your courage there and do that. It's very important.
Perfect. So I can keep asking questions, but I want to open it up. Does anyone have any questions so far?
Yeah, I have a quick question, actually two. Because okay. Firstly, I appreciate camera to organize this meeting. I know there are a lot of effort, a lot of time, especially during this difficult time. We and our students sincerely appreciate, and for our guest speaker, we do appreciate to inspire our students to have a better idea of their future career. So I have two questions so far. First one is a general question. Like Rob and Gary mentioned, the soft skill is something very important when you guys think about hiring a new employee. So I want to know more, because engineering is different with like a business or sales kind of career. So well, we don't like people. We like people deep and like think, like do things on earth, right? So how can they sell themselves? You already give some example, but I'd like to hear more. And the second question is more specific, because I think Rob mentioned you have a company for do the testing. New generation, because getting the PCB or semiconductor small and small. So well, I'm from college. So in college we use a testing instrument like a oscilloscope. We use a function generator. We do some like that big scale testament. So could you tell our students, say what type of new instrument they need to learn to how to use, and then what kind of new skills they need to master for like a trendy for future career?
Wow, what a perfect two questions for the two panelists here today. I'm an engineer that became a salesman, so I'm going to talk to the soft skills and how do you sell yourself. And Rob is the test guy. You know, he's got a lot on that. So if you don't mind, Rob, I'll take the first one if you want to take the second one over here. Sure. It kind of leverages off of the other thing we just said. How do you sell yourself? Because the interviewer may ask you a question like, well, tell me about yourself, you know, open-ended like that. How do you sell yourself? Well, you know, I work real hard and I got good grades and I really want to work here, you know, that sort of thing. That doesn't tell them anything. Tell them something that you're really proud of that you had a problem with. Well, we got together in this team group and we were given a problem to solve about how to move this canister from here to there or whatever, but give an example of something that was really hard, that you worked with other people and you solve the problem successfully. Give examples of how you get along with people, how you're a creative thinker. Examples or stories are the best way for you to sell yourself and your ideas. You have to show them what your personality is, show them what you know, not just academia. You have to be a little bit assertive on this because they're interviewing you. They want to find out about you. So sell yourself. You have to be confident, okay? You can't be too passive, but you have to be confident that you are the right person for this job. And lastly, what Rob said was very important. When you go in for an interview, do a little bit of research on the company and the people that you're going to be talking to. What I would suggest doing, if they know you're going to be talking to Bob Smith, who's the CEO of this company, or Bill Davis, who's the engineering manager, look him up on LinkedIn, do some research, find out a little bit about that person. Where did they go to school? What are their interests? What are their hobbies? Who do you know in common with them? Those are the things that you can bond with that interviewer, and the interviewer is going to say, wow, you know, you took your time to do a little bit of research before you just walked into the interview. Thank you. Don't ever walk into an interview and say, oh, what do you guys do here at this company? Okay, because people have done that before. They walked in, you know, well, okay, what do you do at your company here, Gary? And it says, didn't you even look it up on the internet? Don't you even know what we do? So do your homework, be confident, and tell stories.
I'm an academic who turned into an engineer by doing the work over 40 years. So mine is not so much book learning as actually having to do it or manage people who are doing it. So to answer your question regarding specifically test engineering, all of the things that you mentioned, all of the tools that you mentioned are very important. Things like oscilloscopes, function generators, DVMs, logic analyzers, and so forth. We use all of those, power supplies, but we have other tools that we use day to day, things like flying probe test systems, things like in-circuit testers, things like boundary scan software and hardware, JTAG boundary scan software and hardware. We also use various imaging tools that are used to diagnose or identify the root causes of failures. Our business has two aspects to it. We have an electronic test side and we have an imaging failure analysis side. And if something fails on the electronic test side, it usually goes over to the imaging failure analysis side. And over there, we have a whole nother set of tools that we use, things like x-rays, things like CT scanning equipment, things like 3D imaging equipment, and various types of software that we use that can take a part, slice it up into various visual segments, and then reconstruct it. And in that reconstruction, you can identify why the thing failed in the first place. So if an individual is really interested in A, the way things work, and B, more importantly, why they fail, if they're really interested in the forensic work that goes into tracking that stuff down, we can teach them the tools. The fact that you don't know the tools that I named coming in, that's not a setback at all. It's intellectual curiosity that's important to us. And if you demonstrate that, then we're going to teach you the tools and you're going to master the job and you're going to enjoy it too.
Those were some great questions.
Thank you so much. Thank you so much for the answers. Just one more question. Our students from college, so before they can find 10 years ago, they can find a job do the soldering, learn something, get a certificate from IPC is important. But now it seems like the manual handling is getting less and less. So do you have like a suggestion to our students? So where they can find their opportunity? Like I have watched some other SMTA's webinar, so building the box. So they kind of across to the mechanical part, right? And also they learn AutoCAD for the drawing electronic design, electronic design by using Eagle or by AutoCAD. So do you business really have this kind of interest in that type of skill?
Okay, let me start on this one. On the skill side, having a familiarity with AutoCAD and pads, soldering and all that will be a big help. A big help as far as familiarity. If you're interviewing for an engineering job, you may not be doing a lot of soldering, but you may be developing some breadboards or prototypes and things like that. So agility and flexibility is pretty important. You can't walk in and say, well, I don't do that kind of thing. When you start in at the entry level, you may have to do all kinds of different things. So the skill sets that you learn, not just academia, but soldering, testing, AutoCAD pads, SolidWorks, familiarities with these tools are a differentiator, and your resume needs to show differentiation. and not just the GPA, but what tools you are familiar with. So it kind of relates to the original question about what can you do to get hired. And if you know you're going to be graduating in a year, practice up on some of these things, because you never know when that's going to come in handy. Okay.
I would add to that, troubleshooting is a dying art. And it's very hard to find people these days who know how to do that. Most test engineers, I'll be blunt, are old white guys. And what that means is they're going to be retiring in the next 5, 10, 15, 20 years. Many of these guys, and they're mostly guys, learned their skills in the military. They were in the Navy or the Air Force, and they were trained in troubleshooting failures in aircraft or on ships, and they learned the hand soldering skills that go along with that. If you're interested, if you're intellectually interested in why things fail, then learning how to troubleshoot is part of that. And that is a very valuable skill to have. And if you have that skill, it'll take you in a lot of different directions. Soldering by hand, do you have to be really good at it? Not necessarily. In most assembly operations, there are usually enough people still who can do that. But what I'm saying is the ability to look at a failure, to diagnose a failure, to look at symptoms on the surface, and then get to the root cause. That's a dying art. There are fewer and fewer people who can really do that. Nowadays, a lot of what we do is plug and play, or a lot of what people are trained to do is plug and play, where they can operate software, push a button, and it will either pass or fail something, but you never know why. And in our business, we're interested in the why. People pay us to find out the why. So people with skills like I just described are extremely valuable.
And one last caveat to that, the typical answer on many other things is, well, there's an app for that, or I'll just Google the answer, something like that. That it may not be in existence right now. You need to do your research on your problem solving and all that, but don't just look at the first thing that comes along. You have to be an innovator and look for new things.
And you need to explain what you're doing. You need to explain to your manager, to your customer, and maybe to laypersons, people who don't have a technical background. You'll need to strip it down to its simplest terms and explain what's going on so that they have a grasp of what it is. And that's another skill that's in high demand. Can you do that? Can you do it in plain, precise language such that those three people that I just described all can understand it? That is also a really valuable skill to have.
Well, that's a very valuable advice. So because electronic development so fast, technology grows so fast. So sometimes at school, we keep learning the old style knowledge. So we don't know which part we need to keep, which part we need to improve, right? So this answer is really fantastic. So I have one more specific question about AutoCAD. So we teach a student to design some like a mechanical part. So do you have a suggestions? What kind of activities, or what kind of project they need to can help them to practice the skills? So I also design some by myself, like electrical lines, like a electrical slot or light bulb, something more like art clip. But for mechanical part, well, electronic students don't have that much of the background. They don't know what is a rib, what is a fig, what is a jig, what is a model, the structure. Me too. But so for AutoCAD, especially for an electronic professional view, so what could be some like a focus they can practice?
Well, if you worked for my company, you could take that part out of AutoCAD and or SolidWorks perhaps, and run it on a 3D printer, generate the part. Then we could put it on a 225 kV microfocus CT scanner, scan the part, put it into software called VG Studio Max, which would then twirl it around from all angles, slice through it using a cursor. You could measure it, and you could also run what are called nominal actual comparisons, where we compare, for example, a step file or an AutoCAD output and see what the deviations are between what was designed in the software and the actual part. And the software will produce a heat map showing you, red being the maximum deviation from nominal, green being spot on to nominal. And you can see exactly how well your part was designed, and more importantly, how well the 3D printer manufactured it.
This is a very cool idea. We have a 3D printer, and we have some like the SolidWorks, other software. So what's a part you mentioned? Like so what part could be? We do say we designed the chassis for a microcontroller like Raspberry Pi or Arduino. So we designed the chassis, or we do some like a finger box. Something like
it could be just about anything. It could be a servo motor. It could be an actuator. It could be a gear inside of that motor. It could be a differential in a vehicle. It could be a flight control surface for an aircraft. An aileron or portion of an aileron going onto the wing of an aircraft. It could be a guidance system for a spacecraft. It could be a prosthetic limb that's going to be transplanted into an individual so that they can walk again, and you're checking for proper fit against a known template. So there are many, many different examples of how that would apply.
Well, that sounds very cool. Thank you so much.
You're welcome.
I have a question for you. So talking about growth potential, what's the difference between a small and large company when it comes to growth potential, and what are some advantages of working for each?
Okay, let me take this one, Rob. I've worked for both very small companies and very large companies. My first job as an engineer out of school was for Texas Instruments, which is a very large company. As an engineer, moved up through the ranks. And then after that, 20 years later, I started my own company. So it was myself and one other person, and we grew it to 27 people. So, and I had a couple companies in there in between. So I feel very comfortable with that, answering this question, because totally different ways of approaching different things. So let me give you the two different scenarios. Same person can operate in both environments, but you need to be aware of what it is. Primarily resources. For Texas Instruments, there was virtual unlimited amount of resources and people. I don't know, we had 2,000 people in the organization or something like that. It was the division I was in. So very deep resources, very deep training. You're required to take 40 hours worth of training every year. There's a management hierarchy where there's people at several levels above you, expectations, performance reviews, profit sharing, and things like that. So as an engineer coming into that environment, if you understand where you're coming from, you can take advantage of that and learn from a lot of other people that are around you. Take advantage of the other training, the other educational things that big companies usually offer. Those are all the positive ways that you can grow in a bigger organization by leveraging it. The disadvantages is that you have a little bit more conformity. There's a little bit more structure, a lot more structure there. And you have to go through different gates and permissions and approvals and whatnot. And things usually take longer than you can usually tolerate, and you'd like to move things a little bit faster, but there's a chain of command to go through, and there's a certain level of politics, if you will. Those are all the things with the big pros and cons of big companies. Now, a small company is better if you like to be agile and a free thinker. You won't have as many guidance. You may be working with other people that don't know the answer. They may have hired you as an electrical engineer and they don't have any electrical engineers in the company. You may be it. So you may not have a mentor inside the company to bond with. So you're going to need to expand out into organizations like SMTA and find other networks to get your answer and bring that into the small company. So you can fly and spread your wings and be the hero of a company very quickly, or you can crash and burn very quickly in a small company. If you don't pull your weight, you're gone. In a big company, they might be able to put you in different job openings and things like that. They got a little bit more latitude on fitting you into little niches. So you got to be much more broad-minded in small companies as you go in there. So you've got to be much more aggressive in there and more of a free thinker in a small company. But they're both very good. I had the pleasure of being a big company and then a small company. But I know people that go the other way around. I think having the big company experience, then when you go out to either start your own company, have a lot more experience at your calling when you start a small company.
I'm a lifetime small company guy, so all of my experience working has been in small companies. The largest one I ever worked in was probably 65 people, and that's it. But I've had as customers and clients many large companies, companies as big as Texas Instruments, IBM, names you'd recognize immediately. So I have a fair amount of familiarity with how they work. And I would say this, in addition to everything Gary said, in a small company, you get the opportunity to learn a lot of job skills. Maybe you are an engineering graduate, but 10 years down the line, you decide, hey, maybe marketing or sales is for me, and I can take this technical background and leverage it into a sales career. And that often happens in small companies where somebody will go into sales and really take off and succeed that way. The other thing I would say is big and small companies complement each other, and SMTA is a great example. We have committees who get together and talk about problems, and maybe somebody in a small company is trying to solve a problem and somebody in a big company has written a paper on that exact problem. And that's kind of SMTA's reason for being, is to bring those two parties together to solve a problem, where the knowledge gets transferred from the big company to the small company and everybody benefits. So I'm not here to say one is better than the other. They complement each other.
All right, I have another question. So this one's kind of a two-parter. So I know that trends sort of come and go, but currently, what positions do you see that are in high demand right now that our students might be graduating and going into? And to counter that, which companies should our students be keeping an eye on as a potential company to work at in the future?
Wow, that's a great two-part question. What companies should you look at? I'd be open-minded to a lot of different companies. I don't know if I would focus too much on one, although your skill sets may be more appropriate for other ones, and the trends and the positions. And clearly, years ago, the traditional skills were much more in demand. If you knew your calculus and you knew problem solving techniques and all that. In today's world, I think as Jan mentioned earlier, technology is accelerating. So you have to be up on a lot of different tools and mechanisms for artificial intelligence and things like that were not even thought of as being in the curriculum before. So part of it, where you look at in demand, right now, as opposed to years ago, the small companies seem to be the ones much more dynamic. I remember when I graduated, there were pretty much everybody was looking to the big companies, the Alice Chalmers and the Raytheons and the General Motors and things like that. That was really the norm when I got out of school. And to me, right now, it seems the inverse. It seems to me most people graduate and they know they're going to be, they want to be in a small company and be there for a couple of years and move on. So the small companies seem to be the ones with artificial intelligence and all that can really use the skill sets of electrical and mechanical engineers along with software techniques. So if you're into any one of those, make sure you have a lot of friends in other areas where you can leverage off software skills, mechanical skills.
I think there's more risk taking in small companies. I think to some degree, this is a generalization and not always applicable, but in larger companies, risk is avoided or minimized, or taking risks are often discouraged for the good of the larger whole and the larger company. So if you're in a smaller company environment, you often will be given an assignment that nobody else knows, not because you're being set up to fail, but because, like I said, nobody else knows it, and the company needs to find out whether the technology is viable or not, and whether they want to adopt it and spend money to adopt it. I had an intern work for me 3 years ago, and we were looking at a particular software package, and her summer project was, here you go. This is the software package. We want you to learn it. And at the end of the 3 months, come back to us and tell us, is this suitable for our company? Give us the reasons why, and tell us, should we or shouldn't we buy it? And that's what she did.
I'm going to tell you a little story right now about my experience co-oping that maybe helps answer this question a little bit too. But back in that day, I was in a company called Alice Chalmers in the custom pump division. We built hydraulic pumps that were 5 feet in diameter and 4 stories tall, primarily mechanical. I'm a mechanical engineer. And they had pump test facilities in there where they take way scale down things that are 8 feet high instead of 80 feet high. And it was very analog. There were mercury manometers and valves and gauges and all the rest of that, and manual calculations with slide rules, believe it or not, or the entry of the calculators at that time. And as a skill set,
does anybody on this call even know what a slide rule is?
Google it, see what you come up with. I have some of those, and they're in the museum now. But anyway, so it was a big company. Alice Chalmers built these big tractors and all these other big companies. But I was the green guy that come in there as the engineer. But I happened to be a minor in software programming, and I was a little bit familiar with computers. Believe it or not, they had some computers at that time, but they were all mainframe computers or some of the very first Radio Shack computers that were out there. And they said, Gary, how are we going to go do this? We have these log sheets and we do calculations and we run all these tests. We have to shut everything down, calculate all these things. I said, well, let's just put it into a computer. I said, and how can we do that? So I was the senior guy coming in there with a familiarity with a computer, and brought computers into this engineering group that was working with, what I'm saying, slide rules and such as that. So find the niche. Trust me, as an old guy interviewing young guys and girls right now, it is amazing to me some of the skills that they have to complement the experience. In my mind, you have to have a balance. You have to have people with knowledge, with experience to guide you on prior techniques, but you need the young people to come up with the free new ways of looking at things. You want to break the mold and do something new, but you don't necessarily want to repeat errors from the past. So look for that diversity, if you will.
Thank you. So Maria has very politely raised her hand, so I'm going to let her unmute herself and ask her question.
Yes, thank you. I have actually two questions. As you said earlier, troubleshooting is a dying art. And I would like to ask, how do you redirect that passion of troubleshooting to component level in today's era, today's field? And my second question is, if you were to be graduated, let's say in the 80s, what skills would you need to have to go out at today's market, job market?
I'm going to take the second question first. Let me make sure I understood you. If you were graduating in the 80s, you said?
Yes. In the 90s, let's say the 80s, 90s, you graduated with an engineering degree in the 90s, and you go out to the job market today after being 20 years stuck in the same job. What would you need to, what would be your skills needed in order to get a job today?
Well, everything is faster, smaller, cheaper, and consumes less power per unit time. So you would have to go through a crash course in the evolution of the technology. Many of the techniques needed to manufacture those products in concept are quite similar, but the degree of automation and the level of precision is many, many, many orders of magnitude greater now, obviously, than it was certainly 30 years ago, but even 20 or 15 years ago. You know, just look at your cell phone, and that's exhibit A as to what I'm talking about. Regarding troubleshooting, the problem that we have now is, again, miniaturization. Stuff is so small. In many cases, things that we did in the 80s, in-circuit testing, for example, is a process whereby you drop fixed probes on a printed circuit board, and you make those probes come into intimate contact with dedicated test points on the board, and then you drive an analog and later a digital signal through them to determine if everything's in the right place, nothing was installed backwards, there are no workmanship errors, and so forth. Nowadays, with cell phone boards, for example, the packaging density is so great, you have no room to put those fixed probes in place there. So we have whole new testing techniques, basically virtual testing techniques that we use, which are more software driven than hardware driven, to achieve the same results. A great example of that is something that was designed in part at Gary's old company, Texas Instruments, called boundary scan technology, which is used to run signals from one end of the board to the other through 4 pins on a device to determine whether there are open or short circuits. Miniaturization has changed everything. When I first learned to program a computer back in the 70s in college, I programmed a Sperry Univac computer that filled up a 2,500 or 3,000 square foot room. I used punch cards, IBM punch cards. We would sit at a teletype machine and punch the language in. This was Fortran programming. And then we would take all of those cards and take them to the computer room, and they would be batch run sometime during the night. And if your program ran successfully, you'd come back in the morning, and there you'd have the printout, and you can read it and determine what it is. Nowadays, all of that computing power is in the palm of your hand. And you get instant feedback as to whether you make errors or not. So that's the difference.
Yeah, Marie, let me expand on that. So you can see by that example, when Rob first started in the industry with punch cards, and he had advanced and held up a cell phone in his hand, and obviously doing a lot of new things right now. So it can happen. I'm going to look at your question number 2 that you were asking. If you graduated in the 80s or the 90s and you're looking for a job now in the 20s and the 21s, the obvious thing is, well, what have you been doing since the 80s and the 90s? Okay, so hopefully you have continued to refine your skills, but if you hadn't, then you do some of the things Rob was talking about relearning some of the new technologies. But don't sell yourself short, because what I'm assuming you have done in the past 20 years is working on your life skills and your soft skills and your communication skills. You now have examples and experience that other people don't have. So you have to be well balanced. And if you are lacking right now in the newest technology, to balance that off, you probably and hopefully have other skills and experience that you have developed in your life that you can bring to bear on your new circumstance. So I would leverage off of the life skills that you have developed in the last 30 years and use those as tools, maybe as teamwork. You know, maybe now you've been on a lot of projects before, you've seen a lot of failures. Failure analysis is the fastest way to learn. How you learn is by making mistakes. How you learn is by looking at the mistakes of others as they design something that maybe isn't doing so well. So hopefully you have a plethora of those life experiences you can bring to bear while you're sharpening up your skills. Hope that answers your question, Maria.
Yes, thank you so much.
Perfect. Well, I have another question for you guys. So this is also another two-parter. Considering that there might be some future entrepreneurs on the call, what is one thing they should consider when they're starting their company? And what have you noticed in the industry? Is there room for competition in certain areas? And what areas do you feel are growing really quickly and getting new companies all the time?
Either one of us could take it. Okay.
Go ahead, Gary.
I'll start on it. Entrepreneurs. Okay. Rob and I both started companies and are been part of it. So moving from the big company to a small company, right after Texas Instruments, they basically sold our division to Raytheon, and my job was supposed to move to the other side of the country. So I went into a startup company that needed somebody that put SMT factories together to put a factory together for them. So I was contracted to come in and lay out, buy equipment, and get everything going. Well, in that 2 years later, the semiconductor market crashed. This companies pulled their funds out of the company, so everybody was instantly out of a job. Right after I hired all of these people, bought all the equipment, set up all the processes and all that. So as I was looking for a job, somebody said to me, you know, well, you've got all this equipment and these people and all this kind of stuff. Do you ever think about starting a company, entrepreneur? Okay. And I said, no, I'm an engineer. I don't think like that. But, and I got to thinking about it and said, well, okay. So we did that. And you kind of have to jump in with both feet like that. You have to see an opportunity. You have to find the right people to work for you. You have to have a product that is really needed by customers, not just something that is really cool in your opinion, but other people have to think that there is a need. So you have to have customers before you start a business. You have to have a solid financial plan. I went into as an entrepreneur and I raised a certain amount of money that I thought was significant enough. It wasn't. You probably, whatever you think you need 3 or 4 times more time and money to get there. So after 1 year of my entrepreneurship, I started running out of money. My business was growing very nicely, but I was running out of cash. So cash is one thing that kills entrepreneurs that have great ideas, great products, great everything. But if they don't have enough cash, they probably are not going to be successful. So those are you have to have a passion in your belly for taking significant risks. If you're an entrepreneur, I essentially leased $2.5 million worth of equipment without any, but that was only because the market was down. Nobody was selling machines. And Siemens was happy to let me have the machines and rent, because if I failed, they would get the machines back. So in a down market, you can actually be successful, buy low and sell high. Right? Rob?
The one thing I would add to that is time. If you want to be an entrepreneur, consider your present situation. If you're working for somebody else right now and you feel the entrepreneurial bug, your present situation is going to change in terms of your time commitment. Because once you own your own operation, once you own your own company, it becomes all consuming. There is no such thing as a 40-hour week. Sometimes there is no such thing as a weekend or a vacation or time off, period. The work follows you wherever you go. And because you're the final decision maker. So you're not just engineering the product, you're selling it, you're marketing it, you're running HR because you're hiring people who are going to build it for you or sell it or marketing it for you. There are finances to contend with, as Gary just said. You need to monitor things like cash flow. You need to monitor supplier relationships. Are you getting the best deal for your money on parts that are going into your product? All of that ultimately lands on your desk. And that's not a 9-to-5 commitment. That's a forever commitment. And if you have other commitments, family, friends, hobbies, you need to think long and hard because you're going to have to make some hard decisions if you become an entrepreneur. The work takes over your life to some degree. I mean, you can control that. I'm not saying it's a bad thing and it gets out of control. There are ways of dealing with that. But the time commitment is immense. And you need to know that with eyes wide open when you go in to do that.
Oh boy, when I started my company, the timing wasn't to my thing because I was out of the job and looking, and then why don't you start a company? And I just did. So it's not like I was thinking about this for years ahead of time, planning this out. I just like, okay, let's jump into it. I wouldn't advise that. The other thing was my wife was pregnant at the time with our third child. So it just happened that she had the baby 2 days before my opening day of my business. So I was very split on time. So I would not advise taking that route. Follow what Rob said and consider everything. The other thing I'll say is you have to be not technology-wise, but business-wise, multilingual. You may be an extremely smart engineer or whatever, but you have to be much more broad if you're an entrepreneur. You might need money. You might be talking to a private equity group, and they're going to look at money. How are you going to, what's my return on my investment? What are you going to do about your taxes? What are you going to do about your insurance for your employees? You know, how are you going to partner with other things? All of a sudden, you're going to have a whole lot of questions that you don't have the answers to. So it requires somebody that can be the business person, the financial person, the technologist, and the person that takes out the trash and cleans the office and sweeps up at the end of it. So it can be very, very rewarding doing that, because if you're successful, it's awesome. Okay, but you just have to make that total commitment.
Thank you. So we have about 5 minutes left. I saw Ryan just unmute himself, so I'm going to let him ask a question really quick.
Yeah, when searching for like entry-level like internship or entry-level applicants, which avenue are you most likely to take in refining your pool of applicants? Like, I know there's networking sites like LinkedIn. Some resumes can kind of be misleading in terms of your attitude or your introversion. Yeah. So how would y'all start in your search?
Okay. Well, Rob, why don't you take the beginning of it, and I'll follow up.
Well, you got two guys right in front of you who are pretty well connected just by virtue of age and longevity. We're still standing or sitting, as the case may be. We know a lot of people, and we're SMTA members, and SMTA members know a lot of people. That's a huge network. And if any of you have ever studied networking theory in mathematics, you know how that works. A lot of that is the basis for some of the search engines that are prevalent nowadays. So that's an elaborate way of saying ask. You can ask me, you can ask Gary, send us your resume. And if we don't have an internship in our company immediately available, chances are we know somebody else who does, and we can direct it to that person. We can help you find people who want to hire you. I've done it dozens of times, and I'm sure Gary has done the same. We are resources, and we're putting ourselves out to you right now. After today, when the lights go off, we're not going away. You can contact Tamara, and she knows how to find us. And you know, within our own limitations, we'll do our best to help you out.
Yes, and I'm just going to add really quick, and then I'll mute myself again. For anyone who doesn't have my contact information, I just dropped it in the chat, so you can email me there, and I can connect you with both Rob and Gary.
Okay, and then to follow up also, I was on both sides of this equation. I was an intern co-op engineer working for a big company, so I had to find that job, and I've also been on the other side of the equation, what you asked about, Ryan, hiring. So the two ways I've found to do this at Texas Instruments, I had two co-ops working for me, two different co-ops every semester for 10 years. So I had 100 interns. Within a big company, there's a whole mechanism of how Texas Instruments brings in interns, okay? They have a whole network and, like you say, LinkedIn and all the rest of it. I get the sense that you're talking more on the small company side, which is similar to what I did when I started my company. So if I was a needing hiring manager, where would I go to find something? And exactly, Rob, you sent it right on. You do things like you partner with the universities, like I'm partnered with the University of Texas, University of North Texas, and the University of Texas in Arlington. So if I'm looking for internships, the first place I'm going to go to is what are some SMTA student members that are looking for interns. That's the first place I'm going to go. The second place I'm going to go is to some of the universities and professors that are in the area and say, hey, who are some of your brightest, more aggressive students that can come work? You know, the other thing is we all go to our SMTA chapter meetings and whatnot. What really turns me on as a hiring manager is when students come to the chapter meetings, not necessarily even student chapter, but the chapter meetings, and they get involved and ask questions when people come in there. That says they get out of the university and they come into the and network with people that may have some gray hairs or something, and the people that take that step are the ones that that I'm going to look at first before I start going through the website and not even hitting people that I've never even seen before.
Thank you so much.
Okay, Ryan.
Perfect. Well, we are right at time. So I think unless we have any last minute questions, unmute yourself if you have one. Okay, perfect. So thank you so much for everyone joining us on our first virtual joint student chapter meeting today. It's so great that you're all here. Thank you so much to Gary and Rob so much for answering everyone's questions. We really appreciate it. If anyone does need a connection to Gary or Rob, please go ahead and email me at tamara@smta.org. Thank you, everyone, and have a wonderful week.
Bye-bye.
Thank you.
Bye-bye.